Okay, this is a review for your CBA 2.0. This review, I want you to watch at night and go along with this. This is your review to make any notes on the side that you want to. All right, physical properties of matter. When you're talking about an object, you're talking about the physical properties of it. Okay, how can you look at this item and classify it? So, for instance, we're going to take this glue stick. Okay, first thing I can do is I can measure its mass. Okay, that's measured using a balance in grams, and we have two types of balances. We have a triple beam balance and a double pan balance. Okay, I can put this on there and determine its mass. Then I can check magnetism, whether or not a matter is even attracted to a magnet. To do that, I would stick a magnet next to it. If it's magnetic, I could check yes. If it's not magnetic, I could check no. Its physical state. This is what you're used to. Is it a solid, liquid, or gas? Well, it's a glue stick. It's made of plastic. So I'm going to say this is a liquid. I'm sorry, a solid. This is a solid. If I open it up and look inside, normally what comes out, this is empty obviously, but if it was full, it's still a solid. It's not quite a liquid, okay? But I'm not talking about the inside. I'm talking about the outside of this container right here. All right, now, relative density. Whether matter sinks or float. If I wanted to test if this sinks or float, I would just have my beaker of water, drop it in there, and then watch what happens, and that's where I would write sinks or float. Now, is it solubility in water? That means whether matter dissolves in water, soluble. If I put this in that beaker of water and stir it up with a spoon, is it going to dissolve? Obviously, we know not. It's not. So we could put no in that column. Thermal conductivity, whether matter conducts or insulates heat. Okay, so if I put heat to this, is it going to heat up and get hot, or is it going to stay cool in my hand? Well, this is plastic. What happens when you actually put heat to plastic? It melts, okay? So we know that that's not going to insulate, that's going to conduct. All right, and then electrical conductivity. If I hook wires and a battery up to this and a light bulb, is this going to help the light bulb come on? Can electricity flow through this? Well, this is plastic, so we know that electricity cannot flow through plastic. So this is not electrical conductivity. This does not allow. If it does not allow, that means it does not conduct. It insulates. Okay, this is an insulate of electricity. Insulator, sorry. All right, so let's talk a little bit more about relative density. If it's less dense, it floats on top. If it's more dense, it sinks. Okay. Measurement tools, triple beam balance and double pan balance, measure mass. A graduated cylinder measures volume, and a scale, like in your bathroom or at the doctor's office, that measures your weight. Okay. All right, let's talk about constant properties of water. Boiling point of water is always 100 degrees Celsius. Can it be more than that? Yes, it can. Water will start to boil when it reaches 100 degrees Celsius. Now, let's say water is at 200 degrees Celsius. It's still boiling. Oh, you bet. It's boiling and then some. Okay? Now, freezing and melting point of water is always 0 degrees Celsius. This is that ice cube coming out of the freezer type thing. When ice cube's sitting in the freezer, it's at 0 degrees Celsius. That's why it's frozen. As soon as you put your cup in there and you get some out, or you take some out of the freezer and one falls on the floor, the second it hits the floor, it's still at 0 degrees, only now it's going to start melting because it's out of the freezer, and now the temperature of it's starting to go up to 1, 2, 3, 4, and so on. But the second it hits that floor, it's still at 0 until probably a few seconds later, then it starts to get warmer, and that's why it's melting. All right, let's talk about changes in matter. The process is condensation. How does condensation work? Well, the gas turns into a liquid by cooling. Okay, remember, if you need to put condensation, put mirror in the shower, because that's what the mirror looks like. It's covered in condensation when you get out of the shower. Evaporation, that's when a liquid is turning to a gas. So you're boiling your water on the stove and you see all that steam coming up, that's evaporation. And the way you do that is you heat it. All right, now freezing, that's turning a liquid into a solid, and you do that by cooling it. And melting, we know, is a solid turning into a liquid, and you do that by heat. Think of wax, candle wax, or an ice cube. All right, let's talk about a mixture. Not a solution yet, just a mixture. That's a combination of two or more substances. Substances maintain their physical properties. An example would be iron fillings and sand. Another could be Skittles and M&Ms, or a Twix bar and a Milky Way. Okay, anything that you can easily separate. So let's just say we had the iron fillings and the sand. What's one way we could separate these two? What could we use? What kind of a tool could we use to separate the iron fillings and the sand? Because they're all kind of little small pieces. Yes, we could use a magnet, and that would attract all the iron fillings and just leave the sand. Good job. All right, now solution. A solution is a combination of two or more substances where the physical properties of substances may change. And your example is salt and water. I probably would have put sugar and water, because if you remember when we talked about solutions on Bill Nye, a solution is really two or more substances that cannot easily be separated. Now, salt and water, we'd have to heat it up and wait for it all to evaporate to separate it. So it's not like real easy, but we still could do it. Sugar and water completely dissolves. Okay, sugar completely dissolves in water, and no matter how much you heat that up, you ain't separating it. It is not getting separated. Okay, think solutions are anything like on the back of an ingredients bottle that has all the ingredients. So let's look at this lotion I have. You've got water. I don't know if y'all can see this. Glycerin, petroleum. Okay, anyway, all these, there's probably 50 ingredients in here, 30, 50 ingredients. You put all these together, you definitely got a solution, not a mixture. I can't pull one of these out. I can't just put all this in here and pull out the sodium hydroxide. I mean, that's not easily. So that's your solutions. All right. Next page. Force, motion, and energy. It's behavior of light. Reflection. That's the bouncing back of light waves off of a surface. Okay, that's where you're just seeing your reflection. Light wave is coming back. Bouncing off, and you're like, hey, there I am. Here's you've got mirrors, tinted windows, shiny surfaces. Okay. Refraction is the bending of light waves as they pass through one medium to another. Examples: cameras, eyeglasses, telescopes, through water. Okay, all of those refract. So every time you put on your glasses, not your sunglasses, but your like regular reading glasses, okay, you're actually refracting light. Every time you're wearing those, you're refracting light. Or if you have contact lenses, you're refracting light. Every time you look through a telescope or a microscope, you're refracting light. Every time you look through your camera on your phone to take a picture, you're refracting light. All right, let's talk about circuits. Here's an open circuit because it's broken right there, right? A closed circuit. Okay, one thing I don't see on here are parallels and series circuits. Series circuit is just one, parallel is two paths or more. All right, let's talk about uses of energy. Here we've got melts. Melts. Mechanical is turbines and dams. Electrical is computers and lamps. Okay. Light, solar panels. These are just uses. Okay. Thermal, ovens and melting. Sound, hearing messages. Okay, these are just some examples of the different. You can always list some more off to the side here. Mechanical is not just turbines and dams, but what about you riding a bicycle? You making the pedals go? That's mechanical. Electrical, your cell phone charging at night. That's electrical. Light, solar panels, the sunlight, okay, the sunshine, that's light. Thermal, anything that's keeping you warm, the heater, ovens, stuff melting. And sound is just anything you hear, okay? All right, force and motion vocabulary. Oh, here, it's even got forms of energy. There's your acronym, MELTS, right here. Okay. All right, let's talk about force and motion. Friction is a force that works against motion. So I'm sliding a piece of paper to a buddy at my table, and the table is real smooth. The friction is not really there. That's why the paper is able to slide. What's going to stop that paper from sliding to my friend? Friction. That could be a rough surface. Let's say we were on carpet and I wanted to slide the piece of paper to my friend. Is it going to go as easily as it did on our desk? No. All right, gravity is the force that pulls objects towards one another. Okay, gravity is the apple falling from the tree and hitting Newton on the head. Gravity is my pen dropping. Okay, gravity pulls that object towards itself. Force is a push or pull, and motion is just movement. Okay. All right. This one we kind of did a little bit in the beginning of the year, but it was designing an experiment. This is the one where we were going to test the eggs, and then we all got in trouble. So example 1, use a spring scale to drag a block on 3 different surfaces to determine if the different surfaces affect the amount of force needed to move the block. So what that means is, let me get my spring scale. Okay, I've got my spring scale. I'm going to hold this up a little bit more so you can see. All right, let's say I want to drag this pen across. Maybe. Okay, my glasses. We'll pull my glasses. We're going to hook the spring scale onto it. Come on. Sorry. Okay, we're going to hook this into it. And we want to see what it's going to take to move it across this desk. Not really a whole lot of friction. Now, what if I put maybe on this paper? Okay, well, that wasn't really working the way I wanted it to. But bottom line is, for using a spring scale, you can actually put stuff to it, hold it up in the air, measure its newtons, or you can drag it across something. And if it's a smooth surface, it's not gonna use as many newtons as it would if you were dragging it across, like, say, sandpaper or carpet. Okay, it's gonna use a little bit more force to pull that object. All right, let's talk about Earth and space. Now we got some alternative energy sources. You've got solar, wind, geothermal, biofuels, hydrofuels. So if you remember, we said Silly, Baxter, Wares, Green, Hats. And if you can remember that, then you can remember S is for solar, B is for biofuels, W is for wind, G is for geothermal, and H is for hydroelectric. Okay? Hydro just means water, geo means earth, thermal means heat, solar, wind, and biofuels. Okay, then we've got WED, causes of WED. The part of your, what causes the weathering part is right here. Wind, water, waves, and ice. Those are the things that cause WED. the weathering. And erosion is just the water moving it out, and the deposition is just where it lands. Okay, so slow changes to Earth's surface are the weathering, erosion, deposition. Weathering, breaking down of rock into sediments. Erosion is your movement of sediments, and deposition is just dropping off the sediments. Okay. Then, now we've dropped off our sediments. How do we make a sedimentary rock? Sediments, sedimentary, see? It's all the same. Well, your sediments are deposited in layers over time. So every time there's a deposition of some sediments, another set, then another set, and another set. And every time another layer gets stacked on top, it compacts down. It's pressing down, okay? And then water makes the sediments stick together. Think about cement. Cement takes like that cement, which is like a powder type stuff, and then water together, and pressure and the water coming in makes it all stick together, and then you're left with this big old nice sedimentary rock. Okay, let's talk about fossil fuels. You've got coal, petroleum, oil and petroleum, which is oil then turns into gasoline, okay, for your car. Natural gas, which is the gas in your stove if y'all have real flames on your stove. It's formed by dead organisms that underwent heat and pressure for millions of years. Okay? And then your renewable resources are your air, plants, animals, and water. These make up these. All right. Biofuels, as you remember, is made from corn. Think of it, organisms, organics, corn, biofuels. All right, let's talk about some cycles in space. In this cycle, what happens? Well, you've got day and night. Day and night is caused by Earth spinning on its axis once every 24 hours. Okay, and when we say spinning, what's also called rotate. Now, the lunar means that's caused by the moon revolving around Earth every 29 days. Okay, it's 28 to 29 days. Or 28, depending on the month. Tides are caused by the pull of gravity by the moon every 13 hours. We didn't really talk about that, but it's every 13 hours. And seasons are caused by the tilt of the Earth's axis, and that changes every 3 months. Now, who can remember how often the Earth revolves around the sun? 365 days, okay? All right, water cycle you don't need to know for our CBA because we haven't talked about that yet. But if you do know it, great. If you want to review, that's that. And then let's order our planets from the sun. My very excellent mother just served us nachos, okay? So, and I told you, I always have a hard time remembering which M is which. But because our scientists and our astronauts have been working on Mars and trying to explore Mars, I know that because it's closest to Earth, like it's our next door neighbor. Right now, Mercury is just too far for humans to go explore. While we haven't walked on Mars yet, we're getting pretty darn close, okay? So my very excellent or educated mother just served us nachos. All right, this is a good review. Watch this video, take good notes, watch it again and again over the weekend. Watch as many times as you have to until you feel like you've mastered each block, okay? If you have any questions about each block, come find me, come ask me, or hit me up with a question on Classcraft. And you know, if you do that, you'll get some extra XP. All right, talk to you later.